Today we're going to be working through a standing waves problem. We are told that we have a string and it is 10.0 meters long and it is vibrating up and down 20 times every 10 seconds. It's also at the 7th harmonic. We want to find frequency, period, wavelength, and speed or velocity. So let's start by drawing what this string looks like. So here we have a string vibrating at the 7th harmonic. You can double check. We have 7 nodes here. So now let's determine the frequency. Frequency, remember, is our number of cycles per time. So we're told it vibrates up and down 20 times every 10 seconds. So 20 divided by 10 seconds is 2 inverse seconds, or we can write that as 2 hertz. Now, period, we use a big capital T to denote period, and period is time over the cycle. So if we didn't need to find frequency, we could just find period by dividing 10 seconds by 20. But since we have the frequency, we can also write 1 over the frequency, so 1 over 2 hertz, which is equal to 0.5 seconds. Next, we need to find wavelength. Wavelength, we're going to use lambda to write that. And if you remember, we have an equation that will relate our wavelength and the length of our string, which is up there. L equals 10.0 meters. Now, if you don't remember that equation, you can always figure it out by just counting how many wavelengths you have on your string. Remember, one wavelength looks like this. So we're just going to count 1, 2, 3, and a half. So we have 3.5 wavelengths for every 1 length of string. We can also write that as 7 halves lambda equals L. And this is where we might find our equation, which is L equals n over 2 times lambda. Remember, n is our number of nodes. We have 7 nodes, so if you put that in, you would get 7 halves lambda. So let's solve this for lambda. So we're gonna have L equals n over 2 times lambda. We are gonna multiply both sides by 2. And we've got 2L is equal to n lambda. Now we can divide by n. So we've got 2L over n is equal to lambda, and n equals 7. So lambda is equal to 2/7 L. All right, so let's plug in our length. That is 2 over 7 times 10 meters, which is going to work out to 2.86 meters. Lastly, we're asked to find the speed or velocity. Velocity is equal to lambda f, or lambda over our period. So if we use v equals lambda f, we can just plug in our numbers from over here. So 2.86 meters for our wavelength and 2 hertz for our frequency. Remember, hertz is just 1 over seconds. So now we're going to get 5.72 meters per second for our velocity. All right, so this question asked us to find frequency, period, wavelength, and speed or velocity. It gave us the length of the string, the number of cycles per second, and also the harmonic. With those, we were able to find the frequency just dividing by the number of cycles by the time. Then we found the period by dividing time by cycles. Also, that's 1 over your frequency. Wavelength, we were able to find using this equation, lambda equals 2L over n, and we know n because they gave us the harmonic. And then speed or velocity is just lambda f or lambda t, so we can find that using our values that we found here.